Hello, we're going to get started. This is the Gaia group. I'm Jane Coffin, and this is Leandro Navarro, my partner in crime for Gaia. We're the co-chairs. If you'd like to see our charter online, just take a look under Gaia. We are and have been rebooting and working with community networks, local access network types, people who are hacking code to come up with interesting presentations that are going to lead us to, happily, a BCP that we're going to work on with all of you over the next months until we get to Thailand. So there's something called a note well. If you don't know what it is, go online and have a look, because it would be useful for you to know what that means. I'm not going to go through it. The last time I did, someone laughed at me and said, Jane, you don't have to read out the note well. So in any event, I also want to be very cognizant of time because crypto's after us. So we're going to try and stick to our timesheet. There are 4 people giving presentations. There's one person who's not here who couldn't beam in otherwise remotely. They'll speak in Thailand. His presentation, I'll show at the very end. It's a link to something he's done on OpenWisp. So Gaia Working Group and IETF Initiative. I'm going to beam through this fast. Global access is a human right, obviously, as we know. There's need for infrastructure. I was actually just up in northern Greece in a community network where people are using university backhaul to help put in a Wi-Fi network. Amazing stuff. And people are rejuvenating purpose. They're bringing in more business. And so we're here to try and bring you back down to reality. Some of you work at a super high level from a technical perspective. You cannot have IoT without the I. You cannot have a smart city without smart. So in some places, there's a lot of infrastructure that's not built. 49% of the people on the planet are not connected. So there are we're working out some bugs here with the new process too. Obviously, there are public policy challenges. Those are some things we might take a look at in the BCP that we're hoping to hack with all of you. But there is increased interest and visibility among a wider community on challenges and opportunities to enable global connectivity. What we're doing also from a research perspective is working with those of you out in the community who are testing different interfaces, looking at different equipment, how it's working. That project in Greece I just mentioned just changed out all of their gear to Ubiquity recently because it's cheaper, better, faster, and also just the price point was there. I'm not here to promote Ubiquity, but I'm just saying the price points have come down so much that local access networks are doable. And we're also here to help foster more collaboration. We all know eye-to-eye contact, working with people, not just online, is also critical. And part of our objectives, which are also in line in our charter, to share more information, to document it. And the documentation part, we're hoping to, Leandro and I'll sit down tomorrow with the terms of reference draft for you. Join us if you'd like. We'll put a note out on the Gaia list where we could meet up and hack it in real time, get it out on the list, have people take a look at it, and then move forward with the BCP. So I'm not going to speak much longer, but some of our outcomes are this connection of people, getting the BCP together, talking to folks like who are working on hacking Batman, BMW, BMX. I was just with some of the Battle Mesh folks last week. There are great fora around the world where some of this is happening, where we can bring in some of their findings as well. So without further ado, we are going to skip to Adisorn, and Adisorn's going to pronounce his last name for you because I always screw it up. But Adisorn is working through the AIT out of Thailand. Blue sheets are circulating. Please pass them. And Adisorn, you're up.
Hi, thank you, Jane, for introduction. So my name is Adisorn Lersinsaptavi, so it's quite complicated. I'm a full-time researcher at AIT right now, and also today I'm come from the I got a fellowship from ISOC as well. So thank ISOC to give the fellowship to me to attend this meeting. So today I will give a brief talk about a darknet. Oh, sorry. Oh. All right. Oh, it's okay now? Okay. So today I'm going to give the brief talk about darknet, which is the community network in Thailand. So this work is combined many work from many people from the AIT team, Interlab team. So this is one of the person who work with in this project. So okay, start with what is darknet. Oh. Okay. Gentle. Okay. All right. Oops. Sorry, I think I messed up with this keypad. Okay, so Darknet is a small community network which is try to provide internet connectivity to the rural area of Thailand, which is the northern part of Thailand. It's called the area is called Masot, which is in the Tak province. So it is also in the border between Thailand and Burma as well. So we started this project from the research project in AIT and since 2013. So and currently we have already, it's almost 5 years and we have already deployed almost 15 remote community already. And we can cover almost 1,000 users. We keep using our network on the daily basis already. So at the beginning, the Darknet is based on volunteers. So we recruit the volunteer, which mostly the student from the mostly undergrad student, to have a camp, like a winter camp during between December and November, because it's a cool time in Thailand at that time. So we recruit the student, and then the student like a camp, and then the student went to the network, right, to deploy, to help the people install and set up the network and teach them how to use as well. And that is a bit of background of that. So in terms of technologies, it's similar to another community network like GFI or A10. We use a wireless mesh network, which is based on the Wi-Fi. So what we do, we create the mesh by using the OSR routing protocols, and we share the internet to the gateway, which is going to be ADSL or the fiber. Instead of hardware, we try to make it simple. We try to use the hardware that is available in the market, like the TP-Link one that you can find anywhere. So at our first prototype, we use the TP-Link MR320. The reason we use that one because it's a portable and it has the battery inside. And also we use that one in terms of when the disaster happening, like what happened, like a tsunami, an earthquake. The villager can take that router and then just can run the emergency network immediately without any preparation. So in 2015, when the Nepal has an earthquake, we send those routers to help them as well to create the emergency network as well. Also, we also have another model which is a bit bigger that provide better coverage areas. And for the outdoor, like we want to provide like a longer link. We use the ubiquity one, which is I think everyone know about that. And of course, we use the Raspberry Pi, which is cool, it's cheap, and to run our services as well inside the village. And it's worth to mention that we also use kind of DIY stuff like a walk that we use them like DIY, do it yourself, point to point. For the point-to-point link, point-to-point antenna that we can extend the wireless college area or the wireless links as well. I could not remember exactly how many performance that we can improve, but I think it's about, if you have interested in that, I can have some, we did some measurement for that how can improve the connectivity by using that work. So in terms of services, we develop many services as well, like we use like an open source to like Kubashili to implement the authentication system, Nagios for network monitoring, and also we develop our own chat application called Dumbo Chat. So the Dumbo Chat is like we are connected to the Line, which is I think the Line application is developed by the Japanese company. But worth to mention that in Thailand people don't use WhatsApp, but people use Line as the chat application. So in this application, the villager can use their mobile phone, connect to that, and they can chat with the locally. But also they can connect to the Line user as well outside. Apart from that, we also develop some kind of the video streamings as well. We cache the high definition videos, mostly like education content, to the router that I showed before. And also recently, we also developed kind of prototype for IoT called Canalin, which is like modeling the hairs as well to measuring the pollution that's happening in those areas. So it sounds good, right? So the Darknet is keep working for some time and then it's quite okay. But however, once we launched the network about 2-3 years and we try to sit and think carefully, we found that it is quite difficult to make the network scale. And also it's quite really challenging as well to how to make the network sustain by itself. So that's why we try to think and some kind of re-engineering that we will try to come up with a new model called Darknet 2 model. So in this model, it's not based on volunteers anymore. It's still volunteerism based, but we still involve many partners. So one of those is like we opened a company, the social enterprise company, which is called Net2Homes, which is going to be like that got the license, micro ISP license as well. So the Net2Home will help us in terms of running the services, do the billings or do kind of managing the networks as well. But Net2Home also gets some support from the Technic Foundation in terms of equipment. So the Technic Foundation do a lot of fundraising to get some support for to help to build the network. And also we have Interlab, which is I'm working for, which is kind of taking care of R&D section. And also we have a local community. So like local people. So normally we try to train them how to familiar with technologies and then we try to build them as a community champions to be the local technician for us. So have a closer look to the model that we have. So the Net2Home will give us some money in terms of research funding, in terms of development. So we do Interlab team because they deliver the new service and product, try to help the network more sustain as much as possible. And at the same time, so right now, and also the Interlab also try to provide technical support, troubleshooting, and the trainings as well to the local communities. So this model is the network is not free, but the local community going to have the user, right? They have to pay a little money for the monthly fee. So this money is mostly going to cover like the internet fee that they have to go to internet, and also some cost for the maintenance as well. At the same time, the Net2Home will try to utilize that money to make the network more sustained by, first of all, they push the money to in terms of development to Interlab teams, and also they also supply the equipment for in terms of installations as well. But in order to utilize that money more wisely and make the network more sustained, we try to push the revenue back to the local communities as well. So what we try to do, since we have a lot of training to train the local the community champions, right, the local technicians. So now we give them the installation cost as well. So the local technician can have some kind of some money to help the network for installation. So and that is the part of business model that we have right now. So the model is working quite well. So I might have working quite well for some time. But in terms of research that I'm working on, it's for the R&D team. So what happened? So we this is some kind of problem, the research problem that we found. Like we did some analysis by looking to the traffic measurement and also some social interviews since 2015. I think I present this slide in Gaia 2015 in London as well. So what we did, we want to look into some kind of social communication, what people are using in the village, and we found that people are using Facebook, which is quite pretty normal, and also use Line application. As I mentioned, this is #1 chat application using in Thailand. People using Instagram and the email. So what we found that 80% of the user that using in the village, right? So they have the contact inside the village, and looking to the traffic that the message are exchanging, most like 10 to 20% are the message that keep in local. But however, looking to architecture that we have, all the village have their own gateway and they have to go to the internet. But we don't have any local link to try to link them and keep the traffic local. That's the problem that we found. We tried many solutions, try to using Wi-Fi or maybe multi-hop, but since the environment is quite challenging, so in the hills type, and then there's no light outside to help them to use the Wi-Fi. So the Wi-Fi is not applicable for us. So recently, we get a lot of support from the Gaia mailing list. People just introducing a lot of benefit from the TY space. And last year, we got some support from the Thai regulators that give us some research funding to do some kind of deployment for the TY space. And also, we also got the license from them, from that 770 to 790, 470 to 790. So the first thing that we have to do for this project, so we try to do a lot of measurement or in terms of spectrum, try to build the database for the nation, for the nationwide database, right? So we got a lot of support from ICTP, as we would mention that Marco Senalos and Hermano for the spectrum measurement, and this is some example that we did the measurement in the darknet, and we can see that more of the spectrum are quite free at the moment. So as the next step, we want to demonstrate the benefit of TY space by linking the village by using the TY space to that is architecture that we are doing right now. So we try to connect the 4 villages to the TY space link, and equipment that we're going to use is going to be the Carson, which is based on IETF A02.11 AF, which is quite similar to the Wi-Fi as well. Apart from that, it's not only the white space going to help us in terms of backhauling, try to connect the villages far away. But looking to some example here about in terms of coverage area, you can see that the yellow square is a coverage area that we can provide by the mesh. But we also have a lot of requests from the people who live in the red circle, which is not really far from our network. But however, we try many solutions by the multi-hop communication or Wi-Fi, even though they work with the long-range communication, but the performance is very poor. So how to solve that one? Since we already have the license from the regulator, right, to use the TV band. So we're looking to another solutions as well by working with Microsoft Research UK, try to use the LTE small cell solution, which is also running over the TV band. So, and this is the last architecture that we have. We have the fab, which is going to be the base station that can provide the LTE signal, LTE connectivity to the end user. And the end user is going to be the MiFi, which you can put a SIM card and then get the signal from the fab, and they can provide the Wi-Fi connectivity to the end user. And the fab have to connect to the database, which is based on the POL standardization, and for the and have SCP agent while connected to the mobile core, which is a VM. So we have to run. Now we don't need any further equipment for the mobile core equipment EPC. So everything is running based on the software, is running in the cloud. But sadly, the cloud that we use is Microsoft Cloud, and the closest one is in Singapore and Hong Kong. So this is the closest one that we can find. And this is some performance benchmarking that we have. We did in Cambridge. They did in Cambridge. So so they have the pretty good bandwidth in terms of 75, 25 in terms of download and upload. The active user going to have 16 users at the same time, and the coverage area is quite pretty good as well. We have the 4 kilometers in diameters, and also the good thing that I have to mention is like the user who use a MiFi, they can keep that equipment inside the house, but they still got the signal. So what we try to do this year, we try to replicate the same thing that we have done in Cambridge, but by changing environment from the urban environment to the real rural environment in darknet. Okay. Okay. Just to summarize, this is architecture. I think I don't have much time to go for that, but I already published this one to the NRW as a poster. So if you want to go for detail, just download the paper. I think it's going to be available soon. And finally, I would like to some kind of key takeaway. What could being the time they become the successful? I think the key thing is going to be about a strong cooperation between key partner that I already mentioned, R&D team from the net to home companies, and from the engagement with the local communities. And also the key takeaways, another key takeaway is like the technology should be simple enough that the local people can understand what is going on, and they can use and they can reproduce. And also, we also need to engage to the local people as much as we can, not only giving them the technology, but we have to push them some kind of benefit like revenues, or as we have here, you can see that the guy over there, his name is Kun Sampon. So we trained them at the beginning, but now he worked with us, and then he can keep the local this job as a second job for him for living. And last to mention that so Tainis is going, since we run the first model from 2013 and 2002 up to 2016, right? So we can deploy just one village per year. But now, since we changed the model to the Darknet 2 model last year, so we were able to deploy 11 village already since from last year to up to now. So okay, I might skip this one, I think. And okay, I would like to thank to our team, that is from Professor Kanjana, who is one of the internet pioneers, and he's running the labs as well, Dr. Mongkon, Dr. Pinan, and this is all the team that we have, including me. And I would like to thank you to our sponsor, Technic Foundation, NBTC, with the Thai regulator, ICTP, so Cambridge, where I used to work before, Microsoft Research UK as well, that give us some funding in terms of equipment for LTE. And finally, I would like to thank ISOX as well to give me the fellowship to come here. That this is the word to mention. So even it's a very good opportunity for me to learn about what IETF and then to give the work. So last but not least, you know that the next IETF is going to be in Bangkok, right? So we also are organizing another conference as well. It's called ASEAN Tech, which is sponsored by SIGCOM. So the deadline for submission is going to be in August, but just the conference just be right next to the IETF. Just IETF is going to be on Friday, right? So on the Monday, we're going to have the intake. So please come and join us in Bangkok. Thank you very much.
So we have time for Q&A. Time for Q&A. Does anyone have any questions for Adesorn?
Daniel, thank you for bringing this. It's fascinating work you're doing. I was intrigued. You had on one slide, though, I just have to ask. You said that a walk was a DIY P2P antenna.
DIY, right? Okay. The walk.
The walk, yeah.
Yeah, it's just the cooking pan actually. Yeah, this one.
All right.
Okay. Yeah, up there.
Do they make?
So it's a simple work that we use in the kitchen, but what we did, we attached that small router over there, to that one to create the point-to-point antennas.
I mean, that's awesome.
It's funny, but it's work. So.
Any other questions? And Adesorn, are you here all week?
Yeah, I will be here for the whole week for the whole IETF. If you have any questions, just please stop by. So I'm happy to answer those questions. Thank you.
And just a side note on the project that Adesorn mentioned with the TV whitespace use, we've had a very interesting time when we've been working in some organizations to talk about the importance of the use of TV whitespace. In fact, we've had some massive opposition. And so what you see is active use of TV whitespace and working with the regulator. So that's part of the reason we do what we do on pushing some of the policy regulatory issues, because there's still opposition to unlicensed spectrum. There's opposition to use of TV whitespace. So this isn't insignificant. Nael, you're up. The next person speaking is Nael from our team, who's sitting in front of me. So he's going to talk about a wireless training project that we have online that's been a partnership between the Internet Society and IEEE.
Afternoon, everyone. Wow, quiet silence. So, as Jane has said, I am Nael Harper. I'm the director of Next Generation Leaders at the Internet Society. I'm responsible for fellowships. So, congrats to Adesorn. I'm also responsible for capacity building, online training, some face-to-face as well as blended. So I would have presented on this a project a few years back when it was in the conception stage, where it was just a fledgling project. But basically a bit of background. So we started in 2015 a partnership between IEEE and IEEE and the Internet Society, really to scale or wireless for communities project, which was based in India, I think, where we had done a lot of work with face-to-face training, but it did not scale well. So we decided we would develop this training. So it has a trainer component, which is focused on training different persons so that they can move back to their villages, and then they can train other people to scale. It was also about creating communities of practice in terms of community networks, and really fostering the build out of sustainable, not for profit wireless networks. And it's part of the Internet Society's 2018 campaigns. We're really focused on building out community networks and increasing access. So just a bit about the development process. We engaged a content development partner to help us to build interactive training with learning pedagogy, effective in the instructional design, etc. We work very closely with the IEEE standards group to review and refine the content so that we could develop something that was fit for the purpose. We did a pilot in 2016 to really validate our learning objectives and to really see how the community responded. And that was extremely successful. And then to increase our scale, we did a translation into Spanish. And we've also made sure that we had embedded many processes so that we can ensure that the course continues to meet the needs of the communities, as well as to help us continuously and improve it. So the course content is pretty diverse. It looked at radio physics, looked at site planning in terms of power, looking at backhaul, grounding, erecting different types of masts, antennas, etc. We do a lot of work on networking as well, IP addressing, routing, etc. Security of wireless networks, access points. We've been focusing a lot on more of the low cost and open source platforms. So we've done some work on a Libra router, as well as micro devices, as well as some troubleshooting of wireless networks. In the initial stages, we've had a few partnerships where we thought we can make the most impact. So we've worked with chicks where we're really focusing on building capacity and empowering women in tech across the African region. Done some work with the Free and Open Source Software Foundation of Africa as well. The course is primarily for capacity building, but we've also seen a need for the course around workforce readiness, really to help people to develop skills that are transferable to the workforce. We've done some work with DEF, where because DEF has a number of technicians who volunteer and who don't really have a strong understanding of how to build out these networks. So we've used the training to prepare them before they're deployed to the field. We've been working closely with NOGs in both Africa and Latin America, as well as we've been doing some work with GAISOC chapters. So progress to date, so 2017 was really our first full year of delivering the course. So we trained 20 trainers who can then go back to their regions or their locales and train additional groups. We delivered the online course to approximately 150 persons. we had a lot of webcasts and to do awareness building where we invited practitioners from Latin America and Africa to speak to participants, to do knowledge exchange and lessons learned. And we also did a collaborative leadership exchange on community networks at LATNIC. For those who are not familiar with our collaborative leadership exchange, it's pretty much an unconference that we've delivered at a number of venues, like IETF, LATNIC, LATNOT, and where we allow people to, we crowdsource the agenda. So we don't prescribe an agenda. We allow people to come and to discuss what is important to them. In 2018, this year, we've really integrated our work into ISOC's community network campaigns. Moderator training is currently in progress. The first set of moderator training, we're training 15 individuals from 13 countries. In Q1, we trained 105 individuals from 21 plus countries, and in Q2, we trained 120 individuals from 25 plus countries. And we will be opening a call for applications probably in the next week or two for Q3 training, and that's in English and Spanish. So in terms of our next step, so as you've seen from the previous slide, we're working on how to get this training to scale. So we're working on creating an outsource approach that we can allow communities to self-manage the delivery of the course. And from that perspective, we've designed the course to be portable. So it's standards-based, so it can be surfaced on any learning management system. We're developing an almost finished and offline version that can be run from either an executable on Windows, or it can be run from a USB stick, so that the training can be delivered in communities that have no internet. We're working on some strategic partnerships in Asia Pacific to actually train thousands or hundreds of thousands of individuals, and that's making very good progress. We expect to run a pilot by the end of the year. We're also looking at translation of the course into other languages, so French and Arabic. And we want to make some substantive updates to the content in 2019, and substantive from the perspective of we want to expand from just the technical, and we want to look at different aspects of community networks in terms of how you sustain the network, how you get funds, how you build partnerships, how you create communities of practice, how you help people to use the community networks to create jobs and businesses. That's pretty much it. Any questions?
Hi, Ray Pelletier. Maybe you said this and I didn't get it. How long is the training for?
So the training is 12 modules, and it usually takes about six weeks. So you give people six weeks. We can do a fast track version where we can bring people to a classroom as well, and that would take about 2 weeks.
2 weeks.
Yeah.
Okay, I thought it was something that might lend itself to a YouTube sessions or something where you bring a bunch of people to IETF.
Considering that as well.
Yeah.
Yeah.
Okay. Thank you.
Thank you very much for your presentation. I'm interested in learning more about the training of trainers, TOT piece.
Yeah.
How did you select the trainers? How did you do outreach for the people to be trained, at least at the very first round? And after the TOT piece, was there also some sort of mentorship that was going on to accompany the new trainees into the knowledge that they acquired?
Okay. So in terms of how we trained, we would have worked with some of our partners to promote the training. We would promote it via the different channels like social media. We also work with our different partners in the region, so the NOGs and the Research and Education Network. So we get a very diverse group of participants. In terms of the mentorship piece, part of the trainer course includes how to effectively deliver online training. That's actually an additional module that we had. So teach people how to build online learning communities, how to develop social learning, how to keep people engaged, how to manage people who are not confident. And that's part of helping them to effectively deliver training. There was a third question.
So how did you find the first trainers, the first trainees,
Right.
and the mentorship piece?
So the first trainers came from our different strategic partners, so across various regions. The first trainees, it was a combination. We had a call for applications, and people we had 400 something applications for about, what I would say, 90 spots. And then we also would have had chapters and NOGs who were interested in delivering training to their members.
Thank you.
Khalid Samara, thank you for the presentation. I think I missed some part of the presentation about the region that you cover with the training while you are working with the NOGs. It is like you're covering all the region around the globe, or just a specific region, or you have different places?
We've trained trainers in MENA. We've trained we've trained people in Africa, Europe, Asia Pacific,
Middle East.
Latin America, and the Caribbean, Middle East, and North Africa.
Thank you.
Okay.
Hi, I'm Addison. So I have a little question. So in terms of training, I might miss something. So do you have, provide many, in terms of language, you have like many set of language for the training?
Well, right now we only have English and Spanish, but we're working on expanding to other languages. Interestingly enough, we're working on a partnership in India, and part of that partnership will be translated into local languages. So probably Urdu or some other language, or the Hindi. And we're also looking right now actually at translating it into Arabic for 2018.
Okay, thank you.
No problem. Any other questions? Okay, thank you.
If anybody is interested in us translating it into another language, maybe Thai, we'd be happy to talk to you about that. Talk to Niall. Leandro from UPC, University in Barcelona, is up, partner in crime, and also someone who's part of GUIFI, which is one of the biggest community networks in the world.
Thank you. And by the way, if you want to volunteer, there's an Etherpad where we are collecting the notes. So I'm happy to get some help, especially to report about my presentation. Okay, so I'm coming from Barcelona, from UPC, and also I'm part of the GIFINET community. And we are doing research on different aspects of community networks, mainly in Europe through the NetCommons project. So the presentation has to do with an idea to produce a document that can be useful to collect experiences about the challenges of universal connectivity. Has to do with the existence of infrastructure, and for that, in GIFI we have seen that there are need for radical solutions wherever there is no yet infrastructure, and there's the challenge of how to deal with private deployments. I mean, I understand like companies, telecom companies, but also industries which need to deploy typically fiber in along the public space, I mean land, and how to do that, how to enable that through by the public authorities, and how to help the rest of the community to benefit from that private deployment in public land. So we came up with a mechanism which has to do with a kind of mandatory infrastructure sharing, and this has been developed in terms of an ordinance. It is a kind of local regulation by the municipalities. In Catalonia, we have about 700, and then many of them are really tiny, and they need help to come up with an ordinance which complies with the Catalan, Spanish, European legislation, which is not really easy task. So, well, when we talk about universal connectivity, obviously there are the companies that are regulated to provide universal service, but of course they are not optimized for delivering this connectivity to everyone in the least developed areas, in the ones that there is a negative profit, let's say, and well, I mean, there's a hard time in many parts of the world to achieve that, and the result is what typically the European Commission call it the market failure, and I never know if it's black or white zones without infrastructure, and then there is need, obviously, for not technical mechanisms, which are the technology is there and is sometimes very inexpensive, quite inexpensive, but also policy and regulation mechanisms. So, so the idea is that in the same way as the ISM band for a Wi-Fi has done so much work in bringing opportunities for local communication, but also from the long-distance communication like point-to-point links. The same thing somehow is offered by fiber, which bridges distance across different locations. And you know, when we talk about community networks, I like this analogy of saying, well, I mean, if we are talking about feeding the world, there is a restaurant model that we know it's regulated, predictable, but be expensive sometimes, or the other model, which is self-provision. Wi-Fi, in a way, is many times is used for self-provision, and then particularly the public authorities have the role of arbitrating the use of the public space which is required to deploy infrastructures. Less obviously, I mean, towers in the case of wireless, but ducts in the case of municipal land, or even like undersea infrastructures in the case of long-distance connections. So the idea is to come up with a mechanism where that belongs to everyone creates a return to everyone, while there is some private interest in using that space. So it's about this idea of open access bands for fiber, let's say. So you know, this is like a diagram that shows the huge amount of infrastructure that is already deployed, and it doesn't cover everything. It's just one of the examples of, you see the brown color, it relates to the density of population. So the less populated areas has less infrastructure. In fact, there is more, but it shows. You can see in Africa, for instance, there is a lot of undersea cables and fibers, or at least part of that. There's another alternative map by Steve Song that also shows a bit more coverage, but still there are very many empty areas. So the experience that I'm sharing is based on the work on over the years by the GIFINET Foundation to try to come up with this kind of regulation mechanism to, in fact, to promote the deployment of infrastructures that benefit everyone. The one that is interested initially on the deployment, everyone else in the village, let's say. I'm not going to enter into the details, but we know that fiber has a really high capacity, and but still the civil work effort is very expensive, and infrastructures we know have an economic transformation effect, and there are a lot of changes, especially in Europe. We are facing a lot of regulatory and policy mechanisms to facilitate the deployment of these infrastructures. So basically, the idea is when a company comes to the municipality, this mechanism promotes the deployment of those private cables. But the promoter becomes responsible for the cost of management and maintenance. Has to do it anyway because it's going to get that cable, and then the city council is exempt from the maintenance cost of the remaining fibers. Let's say, so one charge takes the cost of one part that is going to be used for private use. The municipality gets, let's say, free access to the fibers in exchange of allowing this private deployment. And then there is a part of the fiber, let's say, which is under the model of a commons, and then the cost of the usage or the maintenance of that part of the cable is shared proportionally to the users. It's according to a cost-oriented model, and then they have to create an entity like which makes sure that this cost sharing is working. So there are three types of use. The private use, which is the one that created the need for that particular cable. Imagine like a telecom operator, but also we find companies who want to connect their offices with each other. Then there is the city council use for whatever they need. And third, it's the deployment creates some fibers which are open for the use of anyone else, any other operator, any other company in the village, any other school, whatever they are interested in using that infrastructure. That can be implemented differently depending on what is the type of cable, what is the capacity, the number of how it's organized. So basically, you can see in the diagram that usually every tube is divided into different fibers, which are some of them are for private use, some of them are shared, some of them are used by the municipality. In fact, they talk about, they call it minimal structural units, which is how this is implemented, this sharing, this mandatory sharing is implemented depending on the characteristics of cable. So I think you can see here is, well, this is a bit of detail, but, and the interesting part is that this model has been developed for a few years, and now today we are in version 28 of the document. It's quite long. If you're interested, I can share with you version 14. That's the one that we translated to English. The version 28 is in Catalan, if you want to learn a new language. So let's say, I mean, it's about what we are doing there. It's about how to promote the expansion of an infrastructure across public land in a way that benefits the whole community in addition to the promoter. This is the return of minimal cost fiber for everyone else. So public space keeps being a public space. We have applied that into small municipalities in Catalonia for land infrastructure. How about extending it to, let's say, national, international cables, which are over land or under seas. There are a lot of them. Can we do that? I'm curious about your opinions on this, and also particularly how to combine it with the or how to implement it. It can be, of course, I'm not sure if it can be made mandatory or even voluntary. I mean, ask some of the private companies that they deploy fiber already if they are willing to give a fiber or two for public use as a corporate social responsibility action, and then how they can be overseen by a global organization, because we find that these commons can only work if there is an active organization that is taking care of the boundaries and solving the conflicts, and of course that can be funded with the remaining amounts that are in the accounts of universal service funds and other kind of sources. And so, well, I mean, it's about how to achieve universal connectivity by coming up with radical infrastructure sharing proposals that allow to really have access to abundant fiber infrastructure to bridge the gap of the distance. So that's my presentation. If you have any questions, I will be happy. And by the way, the objective is to come up with a document that we can maybe contribute and discuss in the working group. I think many locations, many places could benefit from that. Thank you very much.
Questions for Leandro?
I'm particularly curious if there is any similar regulation in another region. Because in the EU, for instance, there is a directive called cost sharing, which promotes that the sharing of deployment of infrastructures. But what we do is making it more, let's say, kind of mandatory. Okay, thank you very much.
Just an observation, in the village we were in northern Greece, below Mount Olympus, you could see the fiber trenches in the road coming right up into the village. The fiber was dark. You all know how much capacity there is on one little strand of fiber. Dark. So that's why some of the projects for the community networks are coming around, because they can't afford some of that municipal fiber. So this potential question that Leandro's asking about, can we get some shared use, public use? There is a market failure here that we're seeing, obviously, right? If regulators are supposed to help encourage connectivity by enforcing universal service, enforcing the different rules, but people don't have affordable connectivity or connectivity at all, then we've got a conundrum, right? It's an if-then kind of issue. But Spencer's up. He's from University of Washington, yeah? So Spencer, over to you.
Cool. Hi. So, like Jane mentioned, my name's Spencer. I'm a postdoc at the University of Washington, where I work with Curtis Heimerl, who many of you maybe know. And this talk is about our upcoming community LTE project, which we're calling CULTI. So I started with some background on community networking. I'm actually going to skip it because we've just heard about several that I think illustrate a lot of the points. But I'm going to talk to you, if you want to scroll up a little bit, about community cell networks, which is something that is a bit less common. Our lab's background, we've started with a lot of work on smaller 2G networks that are doing just voice and text. They're typically smaller scale than some of the flagship community networks out there. We're talking hundreds of users, 1 to 3 towers. The network architecture of cellular is obviously a bit more centralized, which is good and bad. It's nice to kind of have a single point of failure that will set up, we'll get a tower going somewhere. These past community networks typically have low backhaul requirements, but the biggest thing is that they're still a community network. They're still community owned and managed. I mentioned our past work is in 2G networks, and so we're doing voice and text and just using Twilio typically. Some networks use Skype, but ours, we're using Twilio for a PLMN interconnect. This is a couple of problems. We've had some problems keeping Osmocom, keeping the build and development system kind of sustainable. One of the bigger problems that we found was one of our main operating costs is getting these phone numbers to patch them out to provide use. But the biggest problem with these networks doing voice and text is that they don't provide internet access in the same way, which led us to this question of, well, hey, why not LTE? There's a lot of really good stories here that have been evolving over the last couple of years. When compared to a 2G network architecture, we found that an LTE network is kind of a lot simpler. There's commodity hardware is coming down in price compared to some of our previous experience with 2G base stations. We're going from 8K down to 2. At the same time, over the last couple of years, handset support has been increasing worldwide. We did a study even in a rural community in Indonesia and found that 30% of the handsets that we were supporting on a 2G network were actually LTE capable already if we just came in there and turned it on. And at the same time, these open source stacks are now starting to become available. And so we started looking at that as a tool. And the biggest thing that is important to know about LTE in this space, or developing and building your own LTE network, what sets it apart from prior generations of cellular networking is that it's all an IP substrate. This is a huge benefit. This is my background is more just straight up IP switching and routing. There's probably a lot of other people in this room that share that background. And it's really nice to come in and say, great, we can set this up. And some of the other network functions like voice and text, so on and so forth, are actually still just provided over an IP substrate, which kind of means that they're still just run over IP. You can support a network with or without these functions. It's the simpler version is actually just to build a data-only network, which is what we did. So we've got kind of a simple diagram here that I think was supposed to be an animation, but that's not an issue. You've got the core, you've got the tower, which is an eNode B. The handset's off. It just has a tunnel to the core, and that's it. You have IP addresses, and then that's obviously what it's using. The core is doing NAT to get out to the internet and load web pages. But to add voice and text, you just throw another server on there, give it an IP address, and use DHCP to tell the handset, oh yeah, this is who you should talk to. So when we take out the voice and text, what we're left with is an all data network that we started looking at LTE as just an access technology. It kind of, you can look at it the same way we're talking about Wi-Fi. And it actually is a really great tool in this space for rural access, which is the focus of our lab. We're talking high-speed internet access. Can I help you?
Yeah, Srigunde Valley, Cisco. Can I ask one clarifying question? So
yeah.
in the previous, when you say IP, are you assuming that all the 3GPP functions are there? It's a modified UE with some new signaling, or are you assuming that there's still all the core LTE functions in that architecture?
Maybe I don't quite understand your question. We're not building this on top of a legacy 2G or 3G network. We're just doing all LTE. So the UE is there, the UE supports LTE, and it's communicating with the eNode B in the core to get an IP address.
But the UE supports LTE, sure, but it also supports a number of 3GPP interfaces today. Anybody who builds a LTE UE conforms to the 3GPP specs. That means it supports the NAS signaling. That NAS signaling goes to eNode B to MME, and there's a eNode B to S gateway, P gateway. What I'm missing is when you allocate an IP address, all of those functions are in the picture, right? But
yes.
Here, when you say I'm allocating an IP, are you assuming those functions are existing? It's a completely new signaling that's...
No. This is just a commodity eNode B and then standard MME core.
Oh, standard MME core. So there is MME, there's a S gateway, there's a P gateway, which we are not showing, but it's there in the picture.
Yeah, well, the MME and SPGW, all that is just part of the EPC, which is the...
Okay, so that's the core.
Yes, correct.
So you're having that entire...
Yeah, it's just it's a physically condensed, it's an LTE network with, one physical box doing the core. I'll show you the hardware stack in a couple of slides.
Okay, maybe clarifying question, one more, sorry.
Could I ask you to hold for a sec?
Okay.
And yeah,
That's
okay.
fine,
Could
yeah.
you ask the question after?
No, it's okay, I'm done.
Cool, thank you. So talking about it, when we start looking at it as an internet access technology, we've got good internet access, we've got long range of coverage, way more than a typical Wi-Fi access point. Something that I think also makes deployments kind of easier is that by reducing the number of towers and the number of boxes involved, we're easing routing, we're getting away from some of the challenges that do pop up in like mesh situations, and we're also reducing the number of failure points. And so this brings me to our project, which is essentially a community LTE package, a network in a box project that we're calling Colty. The idea being everything is open source, everything you need to set up and run a commercial or hobby LTE network. And our target goal is trying to simplify network bring up and installation almost to the point of being a Wi-Fi router, where you can plug Wi-Fi routers in and configure them over like a web GUI interface. Obviously, we can't get there because you do have to figure out issues like bands, antenna configuration, essentially buying SIM cards. But all these tasks, when we can't just automate the process, we've been creating step guides, documentation, go here, these are the important parts that you need to look into. The goal is trying to empower people that maybe aren't incredibly experts in this field to set up and do LTE on their own in a small scale. Here's our network's basic architecture. A lot of these rural places that our target deployment right now has a pretty constrained internet backhaul that's just run over a satellite link. And so we had to keep everything essentially downstream of that. There's a lot of networks out there that say, buy our tower, our eNode B, plug it in and use our cloud EPC or use our centralized solution. And that really, we found wasn't gonna fly in a situation where we've got an intermittent backhaul that at most is 1 megabit per second. And so this brings us to our hardware stack. We've got, phone provides kind of a nice, for scale there, where we've got regular LTE supported handsets. The eNode B is a piece of essentially commodity commercial hardware. This is bought by buy cells, but there's a number of eNode B manufacturers that essentially sell these. And then the EPC is the open air interface project. It's all exists essentially in software. And we run it just fine on this relatively small $150 Zotac Z-Box. Kind of riffing on that a minute, there's an interesting dynamic that we've found much more to be the case in LTE than 2G, in that there's a standard interface, S6A, for eNode Bs to connect to core networks. And in the past, this has not been as respected as it is in LTE. So we've been able to find tremendous plug and play success, in that we've tried a handful of different commercial eNode Bs. They all just plug right in, work with the core. We haven't had a lot of problems. And all these things, I think, are encouraging a proliferation of hardware vendors, and we've seen as corresponding, there's kind of been a decrease in price of eNode Bs. They're coming down, which is making essentially from a community networking standpoint, is making everything more affordable and kind of bringing things forward a bit. We're seeing a lot more movement than our lab previously observed in the 2G space. Going on to the core part of it, the EPC box that we've got there. We started with the open air interface project. A lot of the work that we put in initially was kind of fixing some build script errors, getting it up running reliably, starting it, restarting it when it crashes, fixed a couple of seg faults, standard open source work. Our goal is to kind of wrap these up into a nice package that we can release soon. And we currently have some, I wish I had pictures of this yet, but it's not yet built. We have, our summer interns are really working right now on this, the first draft of a web configuration, kind of a status tool to tell us what's running right now, what's the status of it, how can we do this. Right now it's a bit shell scripty, but the goal is to move past that and kind of start moving towards a product that is a bit less cryptic and a bit more usable for people in this space. So once you get past the actual network connectivity, great, we've got IP connectivity. One of the other main tasks that we had to start thinking about was billing services, because really the goal is to be running ISP connectivity, supporting connecting users, but we can't quite do that if we can't keep track of who's using what. And this led us to a couple of big decisions where we took a left turn from standard telecom networks. The first being that I mentioned everything is just run over IP data. So we decided not to bill voice or text separately. That's overly complicated. The margins are better for billing in that context for people running commercial networks in this way. But our goal is community owned and run stuff, so we're just billing ourselves. So we reduced it just to IP billing, which actually makes life really simple. There's a lot of great tools that monitor and log traffic like this. And leads us to our second big decision, which is when we started these discussions with this community, the big thing that we kept hearing was, oh, but can you support WhatsApp? And I was like, well, yes, we have internet access. And we were trying to figure out how to set up voice and text. And everyone said, well, yeah, that's nice, but really we want WhatsApp. So eventually said, well, actually this makes our life easier. So we don't actually provide voice or text at all right now in this initial deployment. It's all Skype, WhatsApp, other over-the-top services that we found the community wanted and preferred to use anyways. So, no skin off any of our noses. And this really just became, again, architecturally and conceptually closer to internet access, or the way you can think of these broader scale Wi-Fi networks. So we wrote a web-based portal. It's got, an engineer's design touch, being myself, but it works. We've got phone number information, current balance. You can buy data packages. You can send data. You can send data packages. You can top up other accounts or send money from one user to another, which is actually a huge service in these communities that oftentimes use this as kind of a for remittances or monetary transfer. There's an entire digital financial services discussion that I'm going to avoid, but it's a useful tool that we were also explicitly asked for. So we got this billing package, we've got this network that essentially runs, and the last thing that we put on top was local services. And by that I mentioned that our target deployment is very backhaul constrained. It's a 1 megabit per second satellite link when it's up. And so the question was, how do we provide network use even in these situations, even when we have a, at best, saturated, at worst, offline backhaul link? So we started locally hosting some web services. Wikipedia is a classic one. Media server is great because we're also asked, well, hey, can we stream our own content? Well, yeah, of course we can do that. So we built those. It's really nice. We're just running them on the EPC. And again, because we have this kind of simple network architecture of IP connectivity, it's as easy as just running a DNS caching server, pointing everyone to the service name.bokondini, which is the community that we're working in. And the last thing that we're kind of iterating on right now that is working, but we're still kind of building out, is OpenStreetMaps also offers an offline kind of, run this on Vagrant. It's a mapping service in a box. And we said, well, this is actually something also really useful. And one of the main things people are doing with the internet, we can also locally host this. So I mentioned we've got our first upcoming deployment is in Bokondini. They previously had a 2G community cell network. I already mentioned the backhaul and that we're doing data only. And I'm literally heading straight out from IETF. I'm going to have a stopover in Seattle to pick up all this equipment, and then we're going straight out. We're going to be there until around mid-August, at which point we should have a lot more concrete information as to kind of how this went and what that narrative looks like. Once we get back, we don't slow down. We've got 2 more upcoming deployments that we're kind of partnering with in Indonesia. There's a group called Mission Airwaves that we've been working with, and they have 2 more sites along the Indonesian coast, also in Papua, that we're planning to build similar networks in. These places currently have no cell coverage, but the flip side is that there's a nearby fiber patch that we apparently can get into somehow. So I'm not quite sure what these details are, but those are numbers 2 and 3, and then beyond that, we're always looking for more people to kind of talk with and communities that we can support. I'm gonna kind of try to move quickly through some of these last slides. There's a couple of 3 more directions that our lab is kind of trying to push things. The first is community-based repair and maintenance and supporting this as like a community structure. The second is in-network services and billing, and then the third is just bigger questions about internet architecture. So the first idea of community repair, we have previously published work on Kai about this, where can we crowdsource via text messages and community incentivizing? Can we get simple repairs going on? One of the main reasons these community networks, when you see hardware failures, 9 times out of 10, there's kind of a lot of low-hanging fruit. Solar panels are dirty, an antenna got knocked over in a storm. There's really great work that our grad student Esther did on, can we send out texts, get people to respond, encourage them, kind of wraps into some of the previous discussions about training, and just, there's a lot of stuff where people were scared to get their hands on stuff, but that's not necessarily has to be the case. And this builds to some of our future work, which is sensor related, where Esther again is building out these kind of boxes. These little dots here on the left are lights that kind of come on, and the idea is, can we be a bit more active and say, we've got something pinging Google, hey, we think there's a satellite failure, things might be this misaligned here. You can have a voltage sensor and kind of interpret from that, or we're seeing low power coming out of the solar panels. There's a whole wide range of work here to kind of create a better information and kind of control service for people to work with and say, okay, here's kind of something that we can patch up with guides, which is kind of another thrust of this work, and just supporting more resilience in that sense, and encouraging more people to get their hands on and fix some of these low-hanging fruit problems. Second thrust we've been talking about, I already mentioned local services, but they intersect really closely with billing, because there's questions about doing free or discounted data rate for some of these local front haul that isn't saturated. There's another question about here about the social benefit of calling and texting via WhatsApp or whatever. We've been talking about offering this straight up free to the community because there's a tremendous social benefit, and these calls are so cheap that they're not going to saturate our thing. Obviously, this butts up against net neutrality concerns. There's a huge debate here that I think is going to start growing a bit going forward. And the third idea is we've been talking about trying to support ways to do web content caching. Everyone always wants to do this. It's tricky, which leads us into my final point, which is talking about some of the internet architecture pushes that are going on. There's a huge question of, are we a telecom or an ISP, and who cares what's the difference? A lot when we're talking about Title II or other types of regulations, emergency services regulations, so on and so forth. Architecturally, what's the difference between doing VoLTE to Verizon or using just Skype, WhatsApp? Well, it's actually a big difference if we're trying to do 2-factor authentication. I can't tell someone just text my Skype address, But really, when everything's over IP anyways, these underlying technologies are really similar. So there's a whole bunch of weird edge points when we started kind of debating and talking about this that kind of lead into what I think is going to be a future research agenda and some of these ideas that we're trying to push on. Thanks a bunch. I just covered a lot of stuff. This is my email if anyone has other questions offline, or this is a blog we've been keeping on the project and we'll continue to update while we're abroad.
Yes, questions for Spencer?
Well, my first reaction is, wow, really great job. Awesome. I think you made some really good trade-offs. And the simplicity is just beautiful. I have one question. Did you have any struggles with the users moving from Wi-Fi to LTE? And did you have restrictions on the cell phone? It was either one or the other. They had manually had to switch. Did you care about making it transparent or having session survivability across moves or anything like that?
That is something we haven't thought about at all. So this target community where we're going in Bokandini doesn't have internet access. They had a 2G local network there. The majority of internet access is people have phones and they use them when they get into Wamena, which is about a 6-hour drive away.
But not very much Wi-Fi usage, you're saying?
No, there's no internet backhaul there.
Oh,
so
okay.
this would be the backhaul.
This is it. Oh,
yes.
Thanks.
Hi, Rafael from the University of Campinas, Brazil. Thanks for the work. I mean, I was looking for this long time ago, and I was planning to do exactly this next semester. So it's good to see that someone else is doing the same. So I'd like to share some knowledge with you. And my question is about, do you know about any commodity hardware project about involving eNode B that can reduce the costs of,
So right now, we were surprised. So our current commercial hardware is sold by Bicells, which is a Chinese manufacturer. We've had good success with them. We were surprised how cheap it was. It sounds like these prices have kind of lowered a lot in the last year. There's also, Facebook has this open cellular project, which we've been talking with a little bit, and that is designed to be fully open, that you can they're providing hardware schematics and stuff. I think LTE support for that is upcoming. This is a space where we're trying to, because a lot of my work is more in software, I'm trying to create essentially on the blog, I've got kind of this buyer's review thing where as we work with different eNode Bs, I want to say, these guys were great, this kind of struggled. I'm trying to be transparent on that process, but really it's not a place where we've done a lot of deep digging, or I haven't personally.
Okay, and about software, have you done some kind of self-configurable or autonomic kind of network management to have the auto healing of the network? Do you have some software progress on that or development?
There's a little bit of, right now it's in kind of a more rudimentary stage of making sure that things reboot when they're needed to and so on and so forth. The network right now we're talking about 2 eNode Bs and 1 EPC. So this is not a mind-blowingly large network. And I think our vision going forward when we start working with more communities is that each one of these will be a self-contained core and 1 or 2 eNode Bs. So the idea is less this, Mondo network and much more we have all these patching into backhaul, the same way you can kind of relate to Wi-Fi access points today where, plug them in and with minimal setup, get it going.
Okay, and about the business model, you have data packages. Is that kind of sustainable for the community itself to have that? Or do you think in the short term or in the long term, how do you see that?
This is another one of these weird points that I think it's hard designing when you don't know where to start. So the transparent solution is, this is going to be owned and run by the community. So their bills are, the 1 megabit per second VSAT connection is actually billed monthly. So there's a trade-off of, we don't want to discourage usage because every second we don't have it pinned to the wall is a second lost. So we have that going on. We have also, we want to discourage use during congested times. The goal is, all extra money is going to be going back into the community. So there's no reason to, there's, questions there about how much should we budget to eventually replace the hardware. And all this is going to be a big community discussion going forward that we don't want to drive too aggressively. Thank you. You're welcome.
Hi, Max Pala, Cable Labs. Thanks, great work. I had the privilege and unfortunate to have to work with the cellular network recently. I'm more of an internet guy, so all this little 3GPP craziness is really sticking with me. One of the work that actually I've been doing for the past 6 months is to work in some other areas, CBRS, particularly unlicensed spectrum. One of the things that we actually did very recently is to try to standardize the authentication, not based on SIM cards, because that might be a problem in using with certain type of devices and that are not fully fledged mobile phones and can actually bring down the cost of the handhelds. So this is something that since you're using software-based type of approach for the core, is something that you might want to take a look at because it might be useful to have.
It totally is, yeah.
The second thing is in this direction, since you're trying to save costs, right, especially deploying the infrastructure, one of the things that we looked at is to work with a company that produces a product called Open EPC. I don't know if you talk with them. Basically, they came out from the Fraunhofer Institute in Germany, and they have a fully software core implementation that can scale up in the cloud from a Raspberry Pi to a cloud deployment, fully containerized deployment. So something that I would suggest you to contact them. They plan to have an open source implementation. They have an open source implementation, but they say it's very outdated. And
this is what I remember.
And they have like 3G, 4G, and they're building 5G as well. So you might, they're very open to have conversation with people. So I encourage you to contact them. And I don't have any business with them, so I'm not involved with that. They're very like 18 engineers and one CEO. So
I didn't realize that they were also that they had more advanced stuff. I looked at the OpenEPC page of it, and I couldn't get it going. And
the name is a little bit misleading. OpenEPC is not open source implementation. They share the source code with their clients, but it's not an open source implementation. They have another one that is not called OpenEPC. I don't remember the name, but it's a little outdated. So the open source.
So that okay.
But they might push them to update also the open source.
Because the Open Air Interface project is essentially that, and it does have a robust community, and it's powered by the Eurocom guys in France. But we're not here to play favorites. An EPC is an EPC, and if one works better,
you might contact them, and
you'd be surprised how much of the project that we've been doing over the last year has been peripheral things around that. Like once you get the EPC up and running, the rest is building a billing package, like all these other things so we can swap this out. But we don't have strong opinions yet.
And so far, they've been open to implement authentication other than AKA, so that might also go in that favor.
Cool, thank you.
I've got a clarifying question. So you did, this is question 30 for ISOC. So the project that you've got, it's not just for the management and the interface, but also for the EPC. That's yours.
The EPC is the Open Air Interface project.
So, and you didn't make any changes for the Open Air software?
We found a handful of bugs we had to fix, and we upstreamed those.
So those are in GitHub?
Yes, yeah, and so the Open Air Interface has a GitLab that's been abandoned. Their GitHub seems to be much more active. I lost a couple months this way.
Okay, and do you foresee in the future people downloading the package and installing their own InnoDB and software out of the box? And
That is exactly the goal. We've been trying to create, I've been working on manuals of how to set this up, like conversely, like manuals of here are all the things that we can't just do for you, like ordering SIMs, but here are vendors that we've worked with in the past. The goal is to make it someone with ideally IP networking experience, but potentially not even that. They want to get coverage out somewhere. How can we help you every step of the way is very much the long-term goal of this project.
And last question. So nowadays, can someone download the EPC, install it via InnoDB and run the network with the current software that is open source available?
The answer is yes. That's what I did. It took me a while to figure out, all right, the build is broken. Why is the build broken? It's supposed to work here. With enough digging and painfully setting up the configurations and so on and so forth, that is what I spent the first couple of months when I started on this project doing.
But what you did nowadays, it's going to be much easier.
Exactly, which is why I was documenting what I was doing along the way, and the goal is to make it easier.
And it's going to be online.
Yes, this is our stuff is. There's a pointer to our GitHub account on that blog. I was going to put that link there too, and there's too many links.
Thank you for the project.
Thank you. Well,
Can you, Spencer, repeat his question?
Are the configuration files up in GitHub?
Samples are? If you're asking about our keys, no.
So we have about
Maybe one-
3 more minutes for questions. Okay.
So what channels are you using? Is it like unlicensed, licensed?
The answer is right now things are licensed. We've been using band 8, I think. So this is one of the things that we've been trying to put together a guide for, which gets pretty tricky because you have this awkward intersection of what bands are supported in a specific country by the handsets, which goes back to what are the popular bands, which then goes into which ones are allowed and so on and so forth.
I
This
guess
is one of the harder parts to write a guide for, actually.
I think this is where CBRS can be extremely useful. Yeah.
Yeah, absolutely.
Thank you very much. And so for the last 5 minutes, because we want to give the next team 5 minutes to get ready, we are keen to work on terms of reference for some best practices, BCP. I don't think we would call it a BCOP, but in any event, if you want to meet up with us tomorrow at some point, Leandro and I are going to sit in a space where we can have room for enough people. If you're interested, we'll put it out on the Gaia list. The idea is to get those terms of reference hacked in the next 2 weeks and then come up with a table of contents that folks can live with, and then use whatever everyone agrees is an open source mechanism to start to work on the BCP together. Anyone have any ideas of what would be best, or any thoughts you want to share with us on what would be useful to you from the community sense? Nothing? Yes.
I guess it depends on how stringent you are with the concept of open source. A GitLab instance with a draft in Markdown seems to work for most other drafts.
Cool.
So that could maybe be an option.
Okay, thank you for that. Any other suggestions? All right, well, thank you very much for your time. Thanks for being here. Over to the crypto guys and everything. We've been taking notes. That's what we've been frantically typing, both in Etherpad and I've done it on Jabber. So if I've missed anything, I'm going to put this up on Gaia for folks to take a look at and let me know if I got some of the acronyms wrong. All right, thanks a lot, Leandro, and I appreciate your coming, and stay tuned and appreciate it.
By the way, feel free to go to the Etherpad and put your names for those who ask questions, and you can also rephrase whatever so we can have our final notes in a few days. I never use the chat.
Hey, how are you? I think so. Yeah. I'm here. I'm just wondering.